So as I said, we're looking at section 4.3 again, reviewing those product, quotient, and power rules from yesterday, and then looking at some more complicated expanding ones, and also looking at that change of base property. So at the top here, there is a review section. There are 3 expanding and 3 condensing. Okay, I want you to try the 3 expanding ones, and then check with everybody at your table. Make sure you're doing them correctly before you move on to the condensing ones. All right, let's see what you got. First one, expanding, log base 4 of 64 over y. What can we do? Okay. Can we simplify either of those pieces? Which one? First one, log base 4 of 64 is really 3. Okay. Second one, of our 3 properties, multiplying, dividing, and powers, we have all of those in here. All right, what's the first thing you did? Okay, so you took this piece here, and the power moved out front. 3 log base b of x. Okay, then. Okay. All right, agree, disagree? Okay. Give me 1 sec here. Shrink this down. All right, last one for the expanding ones. What's our base here? It is base 10. So when we expand this, we have to remember we are in base 10. What does the square root become? It's a 1/2 power. Okay, so powers move out front. We have 1/2 times the log of 100x. Can we pull that apart? Okay, so now we have 1/2 log of 100. Good. We do have to distribute that 1/2 because it applies to both the 100 and the x. And then the first part, log of 100 is really 2. Half of 2 is 1. So we get 1 plus 1/2 log of x. Okay. Questions at all about the expanding part? Anybody? That didn't work, did it? Okay. Condensing, we just do the reverse. All right, so we have log of 25 plus log of 4. We would condense that into, and 25 times 4 you said was 100. Log of 100 is 2 because we are common base or common log there, base 10. All right, next one, we have log of 7x plus 6 minus log of x. Condensing, what would we do? 7x plus 6, we can't do anything with that, but we can put the x on the bottom. Division. Okay. All right, this one. 2 natural log of x plus natural log of x plus 1. What can we do?
Natural log x squared.
Okay, so this 2 is going to go back as a power. All right, we have x squared. Yep, and the addition condenses back into multiplication. Yes? Okay, so in Algebra 2, when you were doing this, we had to do every little step separately. All right, by the time you're getting to the test here, we should be able to do some of these things all in one. Yes? All right. So the new stuff today really isn't new. It's just more complicated looking expressions. But you're looking still for those same 3 rules. Do we have multiplication? Do we have division? Do we have powers? All right. So in the first one, just to make sure we're looking at it all the same way, this would be read log base 2 of the 9th root. Okay. So the 2 is your base, the little 9 there is the root piece. That 9th root applies to all of it, right? Everything's under that. So we can think of a 9th root as a, what power? 1/9. Can we pull that 1/9 out front? Oh, for sure. Perfect. So the 1/9 is going to apply to everything. We're going to wait till the end to distribute it. When we expand this, we are taking the log of each of these pieces. We have multiplication here, we have division, and we also have powers. So we've hit them all. We want to take the log base 2 of a squared. Then what? Plus log base 2 of b minus log base 2 of 4. Okay. Powers go in front. We have a 2 here that we need to move in front. Can we go ahead and distribute the 1/9 as we do that? So this is going to become 2/9 log base 2 of a. Okay. Plus what? 1/9 log base 2 of b minus log base 2 of 4 is really just 2. And when we distribute the 1/9 in, we would get 2/9. Okay. Next one. Again, we have multiplication, we have powers, we have division. Let's see what we can pull apart all in one step. And I'm perfectly fine with you taking multiple steps if that makes it easier for you. Okay? When we pull this apart, we have multiplication here. So where that red dot is, we're going to change that to a plus sign when we expand. So we have the natural log of x to the 5th plus the natural log of the square root of all of this, square root of x squared plus 3. And then because it's division, we're going to subtract minus natural log of x plus 3 to the 6th. And the only thing we have left to do is do what? Move those powers out front. So we should have 5 natural log of x plus 1/2 natural log of the quantity x squared plus 3 in parentheses minus 6 times the natural log of the quantity x plus 3. Agree? All right, at your tables, try the next one. I think that means Nick wants to answer this one, right?
Why do you always do this?
Why do I pick on you? Because you're right here. It's fun. All right. All together, we're going to pull this apart. We're going to take the log, common log of what? Let's take it in some steps because this one has a lot of pieces. Common log of 100 plus common log of x squared plus common log of cube root of 1 minus x minus common log of 3 and minus. Did everybody catch that? Because you're still dividing by that x plus 1 squared piece. Minus the common log of x plus 1 squared. And then moving powers in front and simplifying this first term. What's log of 100? I should say common log of 100. Is 2. Power goes in front, so we have 2 common log of x plus power goes in front as a 1/3. Common log of the quantity 1 minus x, that should be in parentheses, minus common log of 3 and minus 2 common log of x plus 1. Yes? So not really more difficult than yesterday, just more, right? More pieces to pull apart, but still using those same rules. All right. Have to do the opposite, condensing. So first thing to look for when you're condensing is what? come even before the adding and subtracting. Numbers in front, because those numbers in front really were what? They were the exponents. So we want to put them back as exponents. Okay? So this 2 is going to go back as a power. This 1/3 is going to go back as a power. Becomes the natural log of x squared plus the natural log of x plus 5 to the 1/3. What's another way we could write that? Cube root. Yep. And I'm okay with either version. All right. Then we can condense the addition back into multiplication. So the natural log of an x squared times, we'll do the cube root here, cube root of x plus 5 is what allowed. Okay, we'll come to number 3 in a minute. All right, number 2. We do have a 1/2 in front, but look carefully. In parentheses, what are we going to have to do? This 1/2 applies to all of that, right? So let's get that condensed down. It would become what? 1/2 the log base 2 of xy for that piece. So now when we put that square root back in, right, that 1/2 power goes back in, it's over both the x and the y. Okay, so we've got log base 2 of square root of xy. And then dividing, right, because subtraction condenses into division, the 2 going back, we would have an x plus 3 squared in the bottom. Yes? Okay. All right, question 3. We have a lot of pieces. Do we have any powers that have to be put back? Any numbers in front? No. So let's go ahead and condense. If it's plus, it goes back to multiplication. If it's minus, it goes to division. Do we have any minus signs? Yes. So we know right off the bat that we are going to have division. I'm going to just set up a division bar. Okay. So anything that was being added is going to go on top. Anything that was being subtracted is going to go on the bottom, right? So on top, we would have an x and an x squared minus 81. On the bottom, we're going to have this 9 and that quantity x plus 9. Okay, now I'm going to say that there is something more we can do to this. We've condensed it, but the algebraic expression here, can it be simplified? What do you see? X squared minus 81 could be, yeah, we could factor that into x plus 9, x minus 9. Oops, common log, not natural log. So if we factor, what can we get rid of now? Yeah. So it really becomes the common log of x times x minus 9 over 9. That would be your most simplified condensed version. Okay? All right, I'm going to pause the video. I want you guys to try number 4 together at your tables. All right, how many of you condensed this down in one step? Should we try it? Okay. Again, if you're doing it in a couple steps, that's fine. Just check your final answer, see if it matches. So the 1/4 applies to all of it, yes? Which means when we condense this, everything is going to be under what? A 4th root. Do we have division involved? Yes. So we're going to say the natural log of the 4th root of a whole bunch of stuff. Okay. We know we have division involved. Which pieces are going to go on the top in the numerator? The x plus 9 part. And this 3 that's in front of that goes back as a power. So we should have an x plus 9 cubed on top. Okay. We're subtracting the natural log of x, which means when we condense it, that x goes on the bottom for division. And then we are subtracting the natural log of this quantity x squared minus 9. That will also go on the bottom. Now that does factor into what? Plus 3 minus 3, x plus 3, x minus 3, but it doesn't cancel with anything on the top, so I'm not going to bother factoring it. Okay. So how are we feeling with the expanding and condensing? Good? Even the tougher ones today? Okay. The last little piece we're going to review, you learned it last year. It's called the change of base formula. And it's basically saying, so far we haven't used calculators at all. We've simplified things like the common log of 100. We've simplified log base 2 of 4, right? Things that are nice whole number answers, we've been able to do. If we have things like our example here, log base 5 of 140. Well, 140 isn't a power of 5. So this isn't going to come out as a nice integer value. Okay? We can get a decimal approximation using our calculator. But on your calculator, your log keys are only common log and natural log. So we're talking base 10 or base E. Okay? So we are going to convert, when we have different bases, we're going to change them into either a base 10 or a base E. And to do that, our formula says if we're going to take the log base B of M, it is equivalent to taking the log of M divided by the log of B using a different base. Again, we would pick base 10 or base E. Okay? So for our example, we are saying if we're going to take the log base 5 of 140, instead, I can take the log using some other base, I'm just going to write an A for now, of 140 divided by the log base A of 5. So notice that the number down here went on the bottom and the number on top went on the top. Yes? Your base went in the basement. Okay. So we said it makes sense to pick either natural log or common log. So instead of log base A, I'm going to say log base 10. Common log of 140 divided by common log of 5. If I were going to use base E, I could say natural log of 140 divided by the natural log of 5. The only thing you really need to be careful of on your calculators is when you hit that log key, whether it's common log or natural log, it's going to put a parenthesis in there. You need to make sure you close it off before you divide by the second part of that. Okay? So grab your calculators. Some of you at your table use common log, some of you use natural log. And then compare answers. All right, so some of you use common log, some of you use natural log. What did you get for an answer? The same thing, right? What's the decimal? 3.0704. One of our kind of general rules when we use logs, we go out to 4 decimals. Okay? Way back in the good old days before graphing calculators, we didn't have log keys. We had log tables in the back of our math book. So you had to look up logs. You remember that? Yeah, the good old days. Okay. So you guys are going to do 31 to 40 and 63 to 75.